Welcome to the explainer that's honestly going to fundamentally change how you approach your math exams. Think about the movie John Wick for a second. When he gets pushed out of his comfort zone, he doesn't panic, right? He pushes back with absolute calculated precision. And today, we are bringing that exact same energy to the Cambridge 0580 mathematics syllabus. Specifically, we're taking on the silent assassins of the exam paper: data representation and statistical graphs. Okay, let's dive into this by introducing two very typical students we see every single year. Meet Alex and Sam. Now, Alex is what I like to call the data dumper. When faced with a statistics question, Alex completely overloads his answers with raw, unfiltered mathematics facts. He literally writes down every single number he sees, completely ignoring the need for actual analysis. And then we have Sam. Sam's the speed demon. Sam rushes through the paper, sees a chart, guesses the trend, and completely misses the specific command word requirements hiding right there in the question text. Looking at their flawed answers, just bleeding with red examiner pen marks, it's heartbreaking. They're losing incredibly simple marks, not because they don't know the math, but because they don't have the strategy. Look, whether you're taking the core 0580 or you're pushing into 0606, 4024, or even 4040 statistics, the way you structure your data answers dictates your grade boundary. It really is that simple.
So, the overarching data problem we're trying to solve today is the ultimate question that has plagued statisticians and students alike. How do you graph a dataset to show a beautiful, clear visual trend without completely obliterating the original raw numbers? Think about a pie chart. I mean, it shows you a great proportion, but can you tell me the exact raw decimal value of a data point just by looking at a slice? No way. Or think about a bar chart grouped into ranges. You might know 10 people are between 160 and 170 centimeters tall, but do you know how many are exactly 163 centimeters? Nope. The raw data gets totally crushed. It's lost in the visualization. So today, we're going on a journey. We're going to start with those basic visualizations, understand exactly where Alex and Sam go wrong, and then level up to the absolute ultimate solution for this problem: the stem and leaf diagram. We are going to turn those red pen marks into brilliant green check marks. Let's do this.
Here is our battle plan for today. First, visualizing categories and proportions. Second, comparing data with bar charts. Third, stacked and composite bar charts. Fourth, an intro to stem and leaf diagrams. And finally, building a stem and leaf plot together.
All right, Section 1, visualizing categories and proportions. Keep in mind the command word here is usually calculate. Not guess, not estimate, but calculate. In this first exam scenario, we're tracking a teenager's monthly spending habits. We've got clothes at $110, entertainment at $65, food at $40, transport at $20, gifts at $20, and let's say other at $15. Now, if the exam asks you to prepare this data for a pie chart, here is exactly what our friend Alex does. Alex just rewrites the table in sentence form. He says the teenager spends the most on clothes, which is $110. He overloads the answer with raw facts. But what is the command word? The command word is calculate the angle. Alex misses the analytical step entirely. To plot proportions, you absolutely must find the total first. If you add up 110, 65, 40, 20, 20, and 15, you get a total spending of $270. To find the angle for clothes, you cannot just write 110. You must structure it mathematically. 110 divided by the total of 270 multiplied by the 360 degrees in a full circle. That gives you roughly 146.7 degrees. Guys, that specific calculation is literally the difference between a U grade and an A star. So here, the raw financial data has visually translated into angles and proportions. That $110 spent on clothes clearly dominates the chart, representing that 146-degree slice we just calculated. The visualization is stunning, sure, but remember our overarching problem? The raw numbers, the exact dollar amounts, are now completely hidden behind these clean slices. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, moving right along to Section 2, comparing data with bar charts. We've mastered single proportions, but you know Cambridge examiners rarely keep it that simple. They want to test your ability to compare. We're now comparing two sets of related data, the teenager's spending versus her brother's spending over the exact same period. The teenager spends $110 on clothes, her brother spends $10. She spends $65 on entertainment, he spends a massive $150. If you just leave this as raw text, your brain really struggles to find the story, doesn't it? The structure of your data strictly dictates the chart you need. When you have two discrete categories, like a brother and a sister, comparing the exact same variables, like categories of spending,
You have a choice. Do you use a dual bar chart side by side, or do you stack them? A side-by-side dual bar chart lets you instantly see who spent more on food at a quick glance, but it doesn't easily show you their total combined spending. The way you choose depends entirely on the Cambridge assessment objective hidden in the question.
Which brings us perfectly to Section 3, Stacked and Composite Bar Charts. This is where the difficulty curve really spikes, so pay close attention. Actually, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into the explainer.
I'm launching a 60-second data scan challenge for you right now. We have a seriously complex fishing boat data table. Boat 1 caught 304 kilograms of fish A and a massive 1,209 kilograms of fish B. Then we have Boat 2 catching 651 kilograms of fish A and 496 kilograms of fish B. Imagine this as a stacked composite bar chart in your head. Boat 1's total bar is huge, over 1,500 kilograms total. Boat 2's total bar is much shorter, around 1,100 kilograms. If I ask you, which boat caught the most of fish type A, you can look at the raw numbers. Boat 2 caught 651 kilograms, which is clearly more than 304. Boom, easy 1 mark. But Cambridge 0580 papers don't stop at the easy 1 mark. They layer the complexity. I want you to scan this data and think about proportions, because the next question is designed to trap you.
The question asks, which boat's catch had a higher percentage of fish type A? And this right here is where Sam rushes. He sees that Boat 1 has a massively taller total bar on the chart. He sees the huge number 1209 for fish B and just assumes Boat 1 is the absolute winner for everything. He completely misses the word percentage. To get perfect marks here, we're introducing the Peel framework, adapted specifically for mathematics. Yes, Peel. Point, evidence, explanation, link. Your point, Boat 2 had a higher percentage of fish type A. Your evidence, you must show the raw numbers. Boat 2 caught 651 kilograms out of a total of 1,147 kilograms. Boat 1 caught 304 kilograms out of a total of 1,513 kilograms. Your explanation, here's where the math actually happens. 651 divided by 1147 is approximately 56.7%. For Boat 1, 304 divided by 1513 is only about 20.1%. And finally, your link. Therefore, despite Boat 1 having a larger total catch, Boat 2's catch consisted of a vastly higher proportion of fish A. That structured paragraph transforms a messy, panicked guess into an undeniable, top-tier answer.
And now it's time to tackle the boogeyman of statistics. Section 4, Intro to Stem and Leaf Diagrams. Remember that overarching data problem we discussed at the very beginning? How do we chart data to see the visual distribution shape without crushing and losing the raw numbers? Well, this is the answer. By definition, stem and leaf diagrams are a special type of bar chart in which the bars are made from the data itself, allowing original data to be recovered easily. I am incredibly passionate about this specific tool because honestly, it's mathematical magic. Unlike the composite bar charts or the pie charts we just looked at, where your exact $110 or your exact 651 kilograms just got blended into a block of color or an angle, this format miraculously preserves every single original data point. You get the visual curve of a bar chart. You can literally turn your head sideways and see the distribution, the mode, the outliers. But if you need to calculate the exact median, every single raw number is still sitting right there on the page. It's totally brilliant.
So the absolutely crucial point is knowing how to construct one flawlessly under pressure. Welcome to Section 5, Building a Stem and Leaf Plot. I'm setting up a 30-second speed challenge for you right now, based on a classic Cambridge exam scenario, analyzing the raw ages of people on a coach transferring from an airport to a ski resort.
This is what raw, chaotic data looks like. 22, 24, 25, 31, all the way up to 42, down to 18. It's a mess. When Alex the data dumper sees this, he panics. He might just list them all out again in a massive paragraph. But to get top marks, to push back against this exam paper like a strategist, we must systematically break these numbers down into stems and leaves. Think of the stems as the big groups, the tens column. We've got teenagers, people in their 20s, 30s, and 40s. So our stems will be 1, 2, 3, and 4. The leaves? Those are the units. But we can't just throw them on the page randomly. We need a system. I'm deliberately slowing down the pace here because this right here is where the marks are won or lost. Let's walk through these 3 vital steps of construction to transform those red pen marks into green check marks. Step 1,
Extract the stems. As we said, it's the first digit. The 1 for the teens, the 2 for the 20s, 3 for the 30s, 4 for the 40s. You draw a vertical line and put 1, 2, 3, 4 on the left. Step 2, list the leaves, which are the remaining numbers. Now this is the trap. You absolutely must list them in sequential numerical order. If you have ages 22, 24, 25, 23, the leaves next to the 2 stem must be written as 2, 3, 4, 5. They must be evenly spaced so they visually form a horizontal bar chart. And step 3, write the key.
And I need to emphasize this heavily, incredibly heavily. Defining the key is the #1 most forgotten step that costs students points on the Cambridge 0580 exam. For example, key 2 line 5 means 25. Without this key, your diagram is just meaningless numbers floating on a page. To an examiner, 2 line 5 could mean 2.5. It could mean 250. You must tell them exactly what the stem and the leaf represent. If you build the perfect order diagram but forget this single line of text, you will drop a grade boundary. Do not let that happen.
Let's introduce our next real-world application to really cement this, the number 40. This represents a tricky mathematics test marked out of 40 across a class of 32 students. The data we're about to see is exactly the kind of data set that separates the A-star students from the rest of the pack.
I want to challenge you right now. Looking at this data set, 24, 27, 30, 33, all the way down, I want you to mentally locate the stems and sequence the leaves to practice your new skills. Where is your lowest number? I see an 11. Where is your highest? I see a 39. So your stems will simply be 1, 2, and 3. Now mentally scan the teens. We have 11, 14, 16, 18. So right next to the 1 stem, your leaves will neatly be 1, 4, 6, 8. Notice how we're building a visual bar of the data extending to the right while perfectly preserving every single student's exact test score. If the examiner asks you for the median score, you don't have to guess based on a grouped bar chart. You just count exactly halfway through your sequentially ordered leaves to find the precise middle value. It is flawless strategy. To bring this all together, here is the ultimate mathematics success blueprint cheat sheet that literally guarantees top marks if you follow it consistently. Take a mental screenshot of this right now. First, command word decoding. Are they asking you to calculate, compare, or construct? If it's calculate, you better show your fractions and degrees. Second, PL framework application. When asked to compare distributions or evaluate percentages like our fishing boat example, don't just dump data like Alex or rush like Sam. Use point evidence explanation link to build an armor-plated mathematical argument. And third, stem and leaf key rules. Extract the stem, order the leaves sequentially, space them evenly, and never ever forget to write the key. This blueprint is your absolute shield against the exam paper. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Now I leave you with this final challenge. How will you map out the 24 basketball match scores for a season? Think about the steps, the stems, and the key. When the data pushes you out of your comfort zone, are you ready to push back?